Ben Chesterton from Innovate UK, UKRI. I'll talk to you in a bit about what we do, and then around sort of the common challenges, and finally what the UK, particularly UK supply chain, that's what our interest is, can do to go against that. So, Innovate UK, we spent about £500 million in R&D in the UK, so investing in small businesses, startups. I suppose our mission statement is to keep the UK at the cutting edge when it comes to R&D and make sure that all of those new technologies that are coming are happening in the UK. So, a little bit around some of the common challenges. I've put together sort of the top line is projects that or things that we're involved in, which I think are cross-cutting across everything that's been discussed today. And then on the bottom, I think the underpinning technology, the things that we're funding and working on, that I think cut across all of those. And I'll talk a bit in detail about that. So, for example, the Faraday battery challenge. It is quite auto-focused at the moment, but the work that's going on there is going to influence, for example, some of the energy storage that was talked about from OVO. Slightly different technology, they can be a lot larger, the energy densities aren't as important, you can use different chemistries, but there is work ongoing there. And then if you're thinking about, say, the electric aeroplane, we are a long way off that, but if you're thinking about the R&D that's happening now in 10, 20 years' time, so the R&D that's happening very early stages, potentially in universities, probably something might have just been invented today that might end up meaning that an electric aeroplane can happen in 15, 20, 30, 40 years' time. And the Faraday battery challenge is sort of at the heart of a lot of that work in the UK. The second one, and actually what that then leads on to is that last one, the alternative fuels point, where there isn't a solution for batteries, for example, in everything, and that isn't the right solution for everything. So there's work ongoing looking at some of the biofuels that should be used, some of the hydrogen applications as well, and how that's produced. Is it produced sustainably? How can it be used? Where can it best be used? So again, we're funding projects around that, and again, that cuts across all of these different industries. So some of, again, the work that is done in the aerospace industry where there's a lot of this alternative fuel being used in there. So the next two are joined, so the power electronics and electric machines and the small signal electronics. So again, the main difference, particularly with power electronics, is scale across the different applications. So we're talking about, say, in sort of renewable energy, we're talking about in the multiple megawatts and systems that can handle that. And if you're going down to, say, trains, you're talking, say, megawatts or so. If you're talking then down into cars, you're talking about hundreds of kilowatts. And then if you're going all the way down to these small signals, you're talking in 10s, 20 volts. And that starts to become interesting, because that is where the UK is very, very good at, is the small signal electronics and the sensors and the actuators. So I think if you're thinking about, for example, small signals, you've got I'm from sort of generally an auto background, and within a vehicle, it's not electric vehicles, an ICE vehicle in 2020, it's anticipated that about 50% of the value of that vehicle will be in the electronics, electric machines. And of that 50%, half of that is in the software, not even in the hardware. So there's a question there around R&D. What is it we're focusing on? Where should we be focusing? Where's the value in the UK for that? I think if you're looking at sort of, again thinking about sort of the power electronics and the electric machines and the particularly small signals, a current car today will have a high-end car will have maybe 150 ECUs on board. You take off, the door lining of a Land Rover, and it's probably an ECU sitting behind there doing something. In the future, that's going to be consolidated. There'll be 4 or 5, 6 maybe ECUs managing different compartments of the vehicle, managing the safety, for example. Again, there's a lot of disruptive work happening across these spaces, and they cut across all of these different areas. Something the fundamental point to take from this is there is disruption happening. It's, I think, happening in the UK in some cases, particularly if you're looking at, say, CAV or the electric vehicles. But there's a lot of disruption that isn't happening in the UK. Yesterday, I was in Leyland with DAF, and they are really worried because the bus market, so if you're thinking about clean air zones, things like that, buses are going electric. And all cities have got plans, across Europe, loads of cities have got plans to put all electric buses in. And there's a concern there because BYD's cornered that market. BYD isn't a European brand, it's a Chinese brand, and almost that market has been cornered by them. What happens when a similar type of solution comes across that displaces the truck industry? That's what DAF are worried about. I think that's what everyone should be worried about that's involved in any of these technologies across in this room. What happens when an innovation comes from another part of the world? That's why we need to be working together, and it's why we need to be innovating faster and harder than we have done before. So, a bit about Innovate UK, how we work. So if you're thinking about R&D cycles, we sit in the TR levels 3 to 6. You've got EPRC at the lower end at universities, and then, for example, the APC at the higher end, so looking at commercialisation and how those vehicles come in. So a couple of things I'm going to mention today about how, so I've mentioned the challenges and some of the technologies that are coming forward. And then again, I'm now going to talk about the three main areas that I think that we need to be looking at to maintain the UK and Europe's position as being at the forefront of these innovations that are coming. So one is looking at the manufacturing and the process. So when we talk about circular economy, when you think about the way that any vehicle is made, whether it's an aeroplane or a car or a train, at the moment, there is a lot of inherent high CO2 elements of that. Mining and shipping and things like that. There is then a second element to that where we are potentially redesigning and remaking the types of components that are going to go into these vehicles that are going to deal with these different modes of transport. And in that, there is the opportunity to design from the ground up with the circular economy, recyclability, rare earth materials potentially either not being used or designed so they can be extracted again at the end of life. And there's work ongoing. So for example, the Faraday Institution battery that I mentioned earlier, there's work ongoing in designing the battery pouches so that at the end of their lives they can be, the rare earth, well, not rare earth metals, but the materials in there like cobalt can be pulled out again. There's work ongoing looking at how you extract the rare earth metals from the magnets in electric machines, for example. And these are innovations that are happening in the UK and work ongoing to try and disrupt the way that we manufacture our products so that they are less environmentally unsustainable. The second point to look at is the supply chain. Now, the interesting point here is, let's say, I've used a picture of internal combustion engine there because we make a lot of them in the UK. We're very good at it. But that is going to disappear in the coming years. There won't be a desire for that. I think it's going to be the same in the aerospace industry. What happens if we're very good on jet engines and wings, for example? What happens if they change radically and we're not at the forefront of that and it happens somewhere else? How are we going to make sure that we remain at the forefront? So this, again, thinking about those timescales I mentioned earlier, we've got 10, 20 years from university research to what might happen in the real world. And again, with the R&D, our cycles, we're looking at mid-2020s. So when we're thinking about what we invest in, when we're thinking about where the R&D needs to be done, we've got to be thinking about those timescales and thinking about what is going to be happening in the mid-2020s, 2030, 2040, so that we're investing in the right things and aiming our funding in the right areas. So this leads me on to the final question, which is, what does the UK want to be a leader in? What should we be a leader in? So I mentioned earlier that some of the sensing equipment that globally, some of the sensing equipment on anything that's got a sensor on it, a lot of the R&D, a lot of the, not the manufacturing necessarily, but a lot of the work going into that will have started from the UK. We're very good in that area. You can see with CAV and most industries, that type of technology is required. So is that where we want to invest, rather than, say, trying to retrain people that make internal combustion engines to make electric machines? So these are some of the thoughts and the questions that are being asked now and need to be asked now. And I think the answers that we give will determine whether or not we're still building things here in the future. And I think how we define that success will be based on us working together, all these different industries no longer working in silos, working together to face these common challenges, which, as I mentioned earlier, a lot of the time I think are very common. So that's it for me. I don't want to hold you up from your drinks any longer. But yeah, thanks very much.